In this example, I am changing up the notation a little bit, as well as instead of only doing cubed roots and square roots, I'm going to be doing roots that are then multiplied by a power themselves. So first, let's make it into an easier way to look at it. We know that x to the 1/2 is the same as the square root of x, correct? So with that logic, if we, sorry, let me do an aside so you can see what I'm doing. So we're going to take the y to the 3/2. Y to the 3/2 will equal y to the 1/2 times 3, right? Because 1/2 times 3 is 3/2. Or, using the definition of square roots, will equal root y to the 3. So therefore, that top number is actually the exponent that is multiplying your square root. So, using what we just did in blue, plus square root of y cubed minus, and again, the bottom number is the amount the root is, so that's the square root of x cubed. But what happens if we're given this situation, where x to the 4/3? Well, x to the 4/3 would equal x to the 1/3, which we should know is the cubed root, times 4. So which equals the cubed root of x to the 4th power. I'm going to make that in red. Plus the cubed root of x to the 4th. And now we're back to blue. No, we're actually still in green. Red, sorry. Which is the cubed root of y squared. So now we look at that. That looks a whole lot easier. Now if we do have numbers that were given, say, let x equal 16 and y equal 25. Okay? Putting it into the second formula, putting it into star, is much easier to solve for than it would be to put into the original equation. Why? Let's find out. Which equals the root of 16 plus the root of 25 cubed minus the root of 16 cubed plus 3 roots of 16 to the 4th plus 3 roots of 25 squared, which equals 4 plus 5 cubed minus 4 cubed plus, and now see, we have the option of solving this in two ways due to the fact how it was laid out in the original equation. Personally, it's easier to do 16 cubed roots of 4 if 16 was a number that was easily divided or easily cubed. Or we can do 16 to the 4th and then take the cubed root of that. Why? Because look into green. Y to the 4/3 is the same as y to the 4 times 1/3, which is the same as, so now let y to the 4 equal a, which is, so then that is the same as a to the 1/3, which is the same as the cubed root of a, which is the same as the cubed root of y to the 4th. So given these types of exponents and square roots, you are able to do it in whatever way makes more sense to do it in. If you're given something that can easily be cubed or easily found the cubed root of or square root of, do the root first. If not, do the exponent first, and then hopefully you'll be able to break down what you're supposed to be doing. And plus, so that's going to equal 4 plus 125 minus 64 plus, so we're going to go third root of 25 squared. So that's going to equal 65 plus the cubed root of 16 to the fourth plus the cubed root of 25 squared. So equals 65 plus the cubed root of 65,000 times the cubed root of 625. And you can leave your answer like this unless you're told specifically that they want it into one single digit. Otherwise, you're going to have to do what we did on the previous examples and continue to break down these two numbers into something that will be multiplied by 3 in order to factor out